Hey guys, welcome back to the academic powerhouse with your mathematical meathead himself, the realest guy in the room. Bada bing, bada boom. How you doing? How you doing? Let's look at our practice problems, guys. We had the assignment of calculating measures of variability, such as range, such as interquartile range, and mean absolute deviation. Oh, and I bet your mental muscles are screaming at me. They're on fire. Oh my God, he made me do all these. Throwing in decimals. Oh my gosh. But listen, I don't care if you use a calculator. I wouldn't have cared if you used a calculator to help you out. What I care about is how you set up your work, and I want for you to set it up in the way that I'm doing it because it is a very logical flow. It makes sense. It shows me, if I were to look at your paper, your thought processes and how you went through it. And when I look at it and I see that, then I know that you know how to do this stuff. So the addition and subtraction, the arithmetic, don't care so much. I care about the process of getting to the right answer. With that said, let's dive in. Let me explain. I've worked through all these problems. Let me explain how we go through them one by one. Okay? So, the problem. So for each problem, I like to set up a vertical table. I like to set up a vertical table such as this. So I took all the numbers and I set them up vertically in order. Step one. Then from there, remembering how to calculate a mean, which is going to be useful because, mean absolute deviation, I just took the mean or the average of just my given data points. And again, average is sum divided by count. Let me erase that. Erase that here. There we go. There we go. Oh, hold on. Hold on. So anyways, I just took the mean of my original data points and I got a mean. Now I know I need the mean as part of my calculation for mean absolute deviation. For the sake of brevity, I labeled, right, rather than writing out 90.9 over and over and over again in this next column, you kind of see, I instead put a variable to label so it's easier for me to write and repeat over and over and over again. But you could have wrote it. But remember, absolute deviation, I like to break it out. I like to first find my absolute deviation of each of my data points. Now, absolute deviation is again the, the distance away for each data point, the distance away from the center, or in this case, the mean. So for example, 40 is not 90.9. 90.9 is the center. So deviation means how far away is that 40 from the center or the mean, and so forth, and for each data point. So that's what I'm doing here, guys, in this column here. I'm saying for the data point of 40, this first 40, how far is it? So subtract the difference between, how far is it from the center? Well, I got that answer, 50.9. And I just repeated that process for the same number of data points as I have. Okay, you do it for each one. When you do that, you're basically, all you have left at that point, right? Mean absolute deviation, MAD, M-A-D. If you do this column right here, you just figured out your AD. Now you just have to find the M, or the mean of whatever your AD was. Just like we did here. We found the mean of whatever these original data points were. So you can even think of it as MOG or MOD, mean original data, MOD. So this, but either way you want to think about it, right? So this is the key critical step for determining MAD, is finding these deviations. Once you do that, we're going back to calculating the mean absolute deviation. So, or actually, so mean at this point again, sum over count, just like over here when we found out 90.9, sum over count. So you add up all these deviations here, add them all up, you get 272.8. There's 10 data points, so divided by the count, and you get your mean absolute deviation of 27.28. Not bad, not bad. That's how you do it, guys. That is how you do it. I want to see you set up a table just like this, so it's very crystal clear. Right? You could do it all in once, right? When you get to higher level math, sure, all in one column, but don't make it more complicated than it needs to be. Break it into baby steps. That's okay. In fact, even to this day, I still break things into baby steps to keep myself organized. Anyways, yes, please do this for each of the remaining problems. Now, that was one. We had to find out what the range was. Well, remember, the range is fairly simple. Take the biggest number of our data set, so in this case, 149, subtract the smallest number, 40. When you do that, you get an answer. Not too bad there. The next thing you have to do is you have to calculate the interquartile range. Now, it's not hard, but there's a couple of steps you have to do. In order to calculate the interquartile range, first and foremost, right, remember what that even means. It means splitting up your data set into 4 equal parts. Splitting up into 4 equal parts, which means I first got to find the middle of the original. So let's see, I have 10. I have 10. 1, 2, 3, 4, 5. So remember, 10 is an even number, so it means I'm going to have to take two of these. Right? So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I count 5 both ways. There's no clear middle, so I've got to take the average of just these two in the middle. When I do that, guess what? I get another. I get another 90, guys. So what essentially has happened, I created my middle. Remember just like how we find out medians in general. I created another 90. So now I've inserted it there. So now I have this one, this one, this one, this one, and this one. I have 5 on this side, and also I have 5 on this side. So if I want to calculate my upper quartile or my third quartile, right, there's no real calculation. I just count, get the middle. 1, 2, 3, 4, 5. The middle number of 5 is 106. That's why you see that here. And similarly, there's 5 up here. 1, 2, 3. The 59 is the third number there. There you go, 59. And the interquartile range is simply subtracting these two. Subtracting these two. The reason we do interquartile range is because we want to look at our data. We want to find measures of variability, and we want to be able to make calculations based on our data without the effect of really wild outliers, which we may get a lot more into in a future video. But when you do just the interquartile range, it's very representative of what it's very representative of exactly half your data, which is fine for our purposes, right? Again, this is most effective and most applicable for when you have data sets with wild outliers. In this case, they don't appear to be super wild. Actually, maybe kind of. Let's see. Our median was 90. Yeah, I guess kind of this does have a wild outlier. Right? I haven't plotted it to look at it to determine if it really is, but this 149 is really big compared to the middle, the 90, and this is really low compared to the 90. So yeah, it probably does have some outliers. But anyway, we'll save that for later. We're just calculating here. Calculating. But guys, we did it. We did it. First problem, we did it. We found the mean absolute deviation. We found the range. And we found the interquartile range. This is all you have to do for each of these problems. So I'm going to scroll through. I'm going to scroll through here so you can check your answers. Did you follow these steps? Did you get the right answers? If you follow the process, you will have gotten the right answer every single time. Every single time, guys. And that's it. These are the measures of variability. These are the measures of variability. Not too bad. Again, you're probably hating me because all these decimals and oh my gosh. But if you pop them into a calculator, it wouldn't have been as time consuming. And I'm okay with you doing that. Again, the steps, the creation of the table, showing this stuff off to the side, that's what's most important to me. So here we go. Here's the answers to this one. And here's the answers to this one. And again, I'm kind of just scrolling through because once we did the one together, the rest are the same for the most part, right? And I say for the most part because, depending on the number of data sets, it may have some impact on how you calculate your interquartile and your different quartiles, which is all just about taking medians of medians, basically, dividing your data set equally into 4 parts. Here's the last one. That's the last one, guys. That's all the practice problems. That's it. How'd you do? Did you do well? I'm hoping you did well. If you didn't, no problem. I've laid out the work for you. Here's how you do it. So that next time when you see these again, you can knock these out of the park. Okay, all right. So, man, I really hope that assignment gave you a real good pump, all right, guys? Because my mental muscles are burning just from doing all this. I can imagine yours are screaming at you. Screaming at you. But guys, you are well on your way to being ripped, being shredded. You will have the beefiest brain around when it comes to this sort of statistics and all that kind of good stuff. So with that said, I hope you did well. Here are all the answers once again. Until next time, guys, catch you later. Bye.